I'm here to talk about wastewater and about how to create value from wastewater. When people think about wastewater, this is usually what they imagine. It's something quite smelly, dirty, unpleasant, definitely something that you would like to get rid of quite quickly. I've actually also noticed that it's a very efficient way to get rid of unpleasant company when you tell them that I am working with wastewater. But what is actually wastewater? I will tell you a little bit more about that. Wastewater is, of course, this used water from households. It has served in washing and cleaning, in laundry, kitchen, showers, also, of course, the toilet waters. It's a very complex mixture, but it also contains a lot of valuable things. And I will now highlight a little bit the most important valuable things in wastewater. Wastewater contains a lot of nitrogen, and we need nitrogen in fertilizers. Our food production is actually dependent on nitrogen input. Nitrogen is also widely used in different industrial processes in different forms. So we could say that nitrogen is actually a crucial element for life. Wastewater also contains a lot of phosphorus. Phosphorus is also needed in fertilizers. We actually have phosphorus in our bones. Phosphorus is transforming energy in our cells. And recently we have also created new dependencies and new needs for phosphorus. Phosphorus is becoming critical in battery materials. So our laptops, our mobile phones require and need phosphorus. If we think about sources of phosphorus, unlike nitrogen that we have everywhere around us in the atmosphere or in the air, phosphorus is present in mineral formation, so in different kind of rocks. So we need to mine phosphorus from the soil. And we can, of course, do that, but we also understand that these mineable phosphorus resources will be exhausted one day. When we then think about the phosphorus resources globally, at least from the European point of view, those resources are not located in ideal places. Finland is actually the only country in Europe where we have phosphorus resources, but that is definitely not enough for the requirement and for the demand in Europe. So Europe needs to start recycling phosphorus very quickly. Wastewater also contains a lot of energy. This energy is stored in the organic molecules, and it can be recovered and reused. The energy can be used to produce electricity that can be the input for the water treatment process itself, which in the very near future will also include the removal of pharmaceutical residues and other micropollutants from water. It can also serve as internal carbon source for nutrient removal, or then we also have the potential to use the energy for external inputs for other energy demand, and that will make wastewater treatment energy positive. So now I've maybe already convinced you that we shouldn't be talking about wastewater at all. We should be talking about resources. But how big and important are the resources that we can and could recover from wastewater? What are we actually talking about in the big picture? I already mentioned that phosphorus is very, very important as a fertilizer. And in some parts in Europe, the recovered phosphorus from wastewater could supply 40% of the phosphorus fertilizer need. So it's definitely not insignificant. For nitrogen recovery, the picture looks a little bit different because, as I already mentioned, nitrogen is here in the atmosphere. It's everywhere in the air, so we are definitely not running out of nitrogen. And the benefits of nitrogen recovery are linked to energy consumption and the mitigation of greenhouse gas emissions and especially nitrous oxide emission mitigation. When an industrial process was invented to prepare or produce nitrogen fertilizers from air, this was so-called Haber-Bosch process, and it happened about 100 years ago. That revolutionized the food production, but it also had a huge impact on the energy consumption globally because Haber-Bosch process requires a lot of energy. In wastewater, nitrogen is already in a suitable form to be used as fertilizer. So every nitrogen fertilizer that we can actually recycle will decrease the energy consumption and at the same time reduce the climate impact of fertilizer production. In addition to this, we can also, by recycling nitrogen, we can have a positive impact and reduce the climate impact of wastewater treatment itself, because the greenhouse gas emissions of wastewater treatment are very strongly linked to nitrogen. So, what is then needed to achieve resource recovery from wastewater? How can we transfer the valuable content of wastewater into value? How can we transform the existing linear model to circular one? I will give you 3 examples of how we are doing it in our research group. Firstly, we need to develop new processes because the existing ones have not been developed and designed for the production of recycled products. A great example of a new process development is NP Harvest. This startup company was created 2 years ago from our research group, and it offers a solution for nitrogen fertilizer recovery based on selective gas permeable membranes. So we can produce recycled nitrogen fertilizers with it. The development started in small-scale laboratory batch tests. It continued into the development of continuous process and further on to full-scale piloting in real wastewater treatment plants in Finland and in Sweden. Hundreds of small challenges were solved during the development phase of NP Harvest, and now it starts to be a mature process. The demonstration plants are in the startup phase in different parts of the world at the moment. Secondly, we need to modify existing processes to enhance recovery and circularity. A good example of this is phosphorus recovery in form of vivianite. Vivianite is an iron phosphate mineral that can be formed when iron is present in suitable conditions. In the picture behind me, you can see a vivianite crystal or iron phosphate crystal that we identified from a full-scale wastewater treatment plant sludge. So all the elements are actually already there for phosphorus recovery in form of vivianite in our existing wastewater plants. So only some modifications are needed to enhance the formation. But in order to understand the optimal conditions for recovery, we need to understand the reaction kinetics, we need to understand the competing ions, contributing microbial groups, and so on. And after that, we can fine-tune retention times, add volumes, and upgrade our existing wastewater treatment plants to the next level. In the past, comprehensive understanding of consequences and process choices that we made in the processes were not possible because the methods were not actually available to cope with the complex and dynamic characteristic of municipal wastewater. Today, we can deeply understand the processes, and we must make sure that the transition into circular wastewater treatment will happen without violating the energy balance and the carbon footprint goals. Or even better, we could probably achieve the transition while mitigating and improving the climate impact at the same time. So, what does it mean to create value from wastewater? Again, we can transform the linear model into circular one and create value with the recycled products. Quite often, a whole new business or even several businesses are needed to ensure the circular economy solution and the market environment from circular product production until the end users. The fact anyway is that still today about half of the wastewaters globally are discharged into rivers, lakes and seas untreated. Resource recovery and the profit that we can bring with the circular solutions is a very strong incentive to clean wastewaters better. Each gram of fertilizer which is produced with recycled nitrogen or phosphorus is also a gram less in the less pollution in the receiving water bodies. So finally, the highest value that we can create from wastewater is cleaner environment. Thank you.